Okay, hello everyone. Now in this video, you are going to learn about the new chapter which is called reaction kinetic. Okay, so I bet everyone had learned about this chapter before in secondary school, and this time you are going to learn more about it. Okay, but of course, before we begin, we are going to learn some introductions about what is reaction rate, even though I know you all know. All right, so now let's take a look at the introduction. When we are talking about rate of reaction in terms of chemistry view, we are talking about how the reaction change over the time. Okay, so when we're talking about reaction change over the time, we are usually going to focus on the concentration. Okay, so whenever we talk about reaction rate is about the change in the concentration of the reactant and the product with time. Okay, so not only concentration, we can also use volume, pressure, pH, color intensity, but everything must be over time. So anything change over the time. But in matriculation, we are going to use concentration only. Okay, so it is always a positive quantity. As far as I remember, I never heard any rate of reaction in negative. And then the unit for it is mole per liter time, or sometimes you're going to write as m t negative 1. Okay, t is time. So your time can be second. So this is the famous one. So we're going to put S, and you can also use minute, which is mint. Sometimes it can be hour as well. So usually people use H, can even use day. So time is very general as long as it is related with time, regardless we're going to use second, minute, hour, day, it is okay with it. Okay, so when we're talking about the change of concentration of reactant and product, of course we are going to get this kind of graph. Okay, so for example, if we have A as reactant and B as product, so over the time we know definitely A is going to decrease and B is going to increase. So if you were to sketch a general graph, you're going to get a graph like this. Okay, and then when you want to calculate the reaction rate, of course, concentration over the time. Okay, so this is the one that I'm talking about, which is time. So it can be second, it can be minute again, it can be day, it can be hour, depends on the questions. Okay, so reaction rate is inversely proportional to time, which is the shorter the time taken for the reaction to progress, of course, the higher the rate of reaction. Okay. So in this topic, you're going to learn many things like the differential rate equation. We have integrated rate equation. We also have rate law. So there are many things you're going to learn. But in this video, I'm going only to focus on differential rate equation. Okay, so usually for differential rate equation, we want to find how much is the rate of disappearance and rate of appearance. So if you don't really understand what is the term of rate of disappearance, this is disappearance means menghilang, which means if you know what is menghilang, it decrease. So usually this is related with reactant. And rate of appearance from nothing to something, so this one should be related with product, but actually this is more on the terms. Okay, so what you need to understand okay, is how are you going to write the differential rate equation. So that is what I'm going to focus in this video. Now, like if you look at here, yeah, you can see the example, but I'm going to rewrite it again. Now you have A as your product, reactant, and B as your product. So in order, if the question asks you, write the differential rate equation, so start it with rate equivalence to, okay, negative d concentration A over dt. Okay, differential in differential dalam bahasa Melayu is what we call perbezaan. Okay, this is the one that you learn in matematik tambahan lah. And the rate of disappearance for A is actually equals to the rate of rate of appearance or formation for B. Okay, positive. Now what I want to emphasize here, when it comes to writing, you have to write rate. Now some students, they're so lazy, they just write R. If I found out like that, usually I will not give you the marks, okay? And then the second one is the symbol negative and positive. So this symbol is not, it is not related with the mathematical calculation, okay? Rather than this one is actually referring to this one disappear, berkurang, and this one increase or appear or forming, okay? So again, this symbol has nothing to do with your calculation, but you have to add it, okay? Now, if you look at the second example, which is you have 2C and D. Okay, the difference between the above example is that this one has 1 and 1, but here we have 2C produce D. So we are going to write it as rate equals to, now C is the reactant, it will definitely decrease. But since it has 2 as stoichiometry, so we are going to write it as 1 over 2 dC over dt, equivalence to positive dt. Okay, so it is like this. So generally for the reaction, okay, given here A plus B plus C plus D. So what will be the rate expression? Okay, we are going to write it as rate equivalence to negative 1 over A over dt, equivalence to B is still the reactant, so the symbol should be negative 1 over B over dt, equivalence to, now C is the product, so you have to put the positive sign. Now, madam, is it okay if we don't put the sign because it is positive? The answer is no. Okay, you have to put the positive sign. And the last one is positive 1 over dt over dt. Okay, so if the question is asking you write the rate expression or differential rate equation, so this is it. Okay, now let's look at the exercise here. So write the differential rate equation for okay. So you can pause this video and you can do first, or you can just look at my example first. It's up to you. But for this, as you can see, we have our reactant here, nitrogen gas and hydrogen gas, and we have our ammonia as product. So how are we going to write? It will be like this: rate equals to negative d and 2 over dt. We are not going to write 1 over 1. It is weird. Okay, so this one is negative 1 over 3 dH2 dt, which is equivalent to, now ammonia is your product, so you need to put the sign plus. 1 over 2 d and H3 dt. Okay, so this is it. And next one, red equivalence to negative 1 over 2 d SO2 dt. And then plus, plus equivalence to plus 1 over, dO2 over dt. Okay, so there it is. All right. Okay, now let's take a look at these questions. So how are we going to apply the differential rate equation into the questions? So like if you look at these questions, now for the reactions of 2 moles of HI, it produces 1 mole of hydrogen gas and 1 mole of iodine gas. Determine the rate disappearance of HI when the rate of iodine formation is 1.8 exponent negative 6. Okay, so first thing first, write your differential rate equation, which is rate equivalence to negative 1 over 2 dHi over dt equivalence to dH2 over dt equivalence to positive di2 over dt. Okay, now just to give you a little note, like rate of disappearance okay, of HI. Okay, my question to you guys is, where is the rate of disappearance? Okay, is it the whole this or this one only? Or this one only? Okay, which one? Okay, so the answer is, when the question asks you what rate of disappearance of HI, it is actually referring to the dHi only. Does not include the 1 over 2, okay? So rate of formation for I2 is di2 over dt. So the positive sign shows formation, negative sign shows disappearance, right? Okay, so how are we going to calculate? So I will take like this, dHi over dt equivalence to positive di2 over dt. So dHi over dt equivalence to 1.8 exponent negative 6 ms negative 1. Now, these two we bring here, mathematical law, times 2. So we are going to get 3.6 exponent negative 6 ms negative 1. So that is how we do the calculation. Okay? Okay, so let's take a look at this. We try again one more questions. Okay. So, during an experiment at fixed temperature, the concentration of NO is decreasing at the rate of 1.60. So, the concentration is decreasing at the rate of 1.6, which is for this one. So, calculate the rate of concentration decrease in oxygen and this one. Okay, so again, as usual, write first your differential rate equation. So rate equivalence to negative 1 over 4 dt equivalence to negative oxygen, and equivalence to rate of formation for this. Okay, so first we want to look at oxygen, right? Okay, so it should be like this. D oxygen over dt, because we want to find the decrease in oxygen, is equivalent to 1 over 4. And you just directly substitute with NO, which is what is it? 1.6 exponent for ms negative 1. And you're going to get 4 exponent negative 5 mole per second. Okay, so that is number 1. So for number 2, you can choose. You want to use oxygen to compare, or you can also just use the nitrogen oxide, monoxide to compare. So in this case, I just go with this. So we have D equivalent to 1 over 4, 1.6 exponent negative 4, and then times with 2. So here you're going to get at exponent negative 5, ms negative 1. So that is how you do the question.